a laboratory lecture. Turning a diode into a solar cell. In this video, we have an experiment about turning a diode into a solar cell. We will make a small solar panel of 12 diodes. We will power a watch with a small solar panel according to the electrical measurements. We will use two sources of light to power a small solar panel such as sunlight and a light bulb.
This is the type of the diode that I used. It's 10A10. The green ball is negative. The black ball is positive. I will put the link of the datasheet of this diode to my YouTube page. So you need these things to break a diode: the hammer, this one, just like this one, the sheet of marble or iron, just like this one, to break the diode on it, and the sponge, this one. So you have to put a sheet of marble on the sponge in the middle, just like this. Now you can hit a diode to break it, but of course with a hammer. Let's break half of the diode. As you see, guys, there are some lines which make the diode into two parts. As you see, guys, the lines on the diode from all sides. If you bought a diode just like this status, there are two horizontal lines according to a sheet of marble. This is the first line of the diode. And this is the second line of the diode. As you see, guys, the two horizontal lines of the diode Let's break half of a diode. So hit a diode vertically with a hammer at one of the two horizontal lines of a diode. Just like that. So hit a diode softly. As you see, guys, so stop here We want this result. So this is the other plastic part of a diode. As you see, guys, now it's broken. But if you break a diode fully, you will have such this status. As you see, guys, the diode This is the diode after I broke it. As you see, guys, the negative pin and this the positive pin. As you know, guys, one of the pins is negative and the another one is positive. If the diode is broken just like this, it will turn into the solar cell. You can measure this diode by a digital multimeter, even it's open, just like this. Just put the positive of the multimeter to the positive of the diode and the negative of the multimeter to the negative of the diode, and you will see the result on the screen of the digital multimeter. As you see, guys, the negative pin of the digital multimeter is connected to the negative pin of the diode, and the positive pin of the digital multimeter is connected to the positive of the diode. And you will see the result on the screen of the digital multimeter. This one. It's 0.494 volt, as you see, guys. This measurement is for forward bias. Also, we connect the negative pin of the digital multimeter, this one, to the positive pin of the diode, this one. And the positive pin of the digital multimeter to the negative pin of the diode, this one. The result should be .OL, as you see, guys, on the screen of the digital multimeter. This measurement for reverse bias. So when you want to measure the diode, you have to rotate the switch of the digital multimeter to the symbol of the diode. If you expose the diode to the sunlight, it will produce the electricity. The diode will nearly give us about 4.5 microampere and 250 millivolt. This one. If you calculate the power of this solar cell, I mean this diode, it will be about 1.125 microwatt. As you see, guys, the result on the screen of the digital multimeter, it's 252.8 or 7 millivolt. And this is the diode when you expose it to the sunlight. As you see, guys, the result on the screen of the digital multimeter, the value of the current, it's 4.5 microampere, and this is the diode as a solar cell.
Note 1. In this experiment, while measuring the voltage of a small solar panel, the digital multimeter has a resistance of 10 megaohms. Note 2. Imagine the load is connected to a small solar panel directly. Imagine it gives us the fixed open circuit voltage and the fixed short circuit current. If a load resistance is high, the voltage of this load will be high. If a load resistance is low, the voltage of this load will be low. But how about the current of a load? When the load resistance is high, the current of a load will be low. When a load resistance is low, the current of a load will be high.
These are the diodes after I compose them on the electrical board. So these are the diodes as the solar cells. As you see, guys, also you can see the connection. So the black ball of this diode will be the positive pin, and the gray ball, this one, will be the negative pin of this solar panel. All these diodes just make as a small solar panel. All these diodes are just will be connected in series. So the negative of the first diode will be connected with a positive of the second diode, and the negative of the second diode will be connected with a positive of the third diode. just like this until the end. This is a small solar panel after soldering. As you see, guys, the points of soldering. As you see, guys, the result of the current on the screen of the digital multimeter, it's 4.5 microampere, and this is the solar panel. As you see, guys, this is the voltage of the small solar panel. It's 3.71, as you see. If I cover the small solar panel, the voltage will reduce. Now the voltage it's 3.64 volt. When I cover the small solar panel, the voltage will reduce just like this. As you see, guys, it's 2.5. When I take off my hand, the voltage will be back or will increase to 3.7 volt. This is the positive of the small solar panel, and this is the negative of the small solar panel. This is the current of the small solar panel. As you see, guys, it's 5.5 microampere. When I cover the solar panel, the current will be 0, just like this. As you see, guys, when I take off my hand, the current will be back again, just like this. It depends on the sunlight. So when the density of the sunlight is high, the voltage and the current will be high. And when the density of the sunlight is low, the voltage and the current will be low. So I will power this watch with a small solar panel. It's a Chinese watch. I think the manufacturing company is Leica. It's here. As you see, guys, the name of the company. So I'm going to disassemble the watch with a screwdriver and take off the battery from it. Let's disassemble the watch. As you see, guys, I have taken off the iron cover of the watch. This one. This is the iron cover of the watch. Now I have to take off the circuit of a watch. This one. So I need the needle nose pliers. This one. Let's take off the circuit of a watch, just like this. As you see, guys, this is the circuit of a watch. And this the screen of the watch. This is the watch after taking the circuit from it. As you see, guys, it's empty. Nothing inside it. Let's take off the battery of a watch. As you see, guys, this is the battery of a watch. It's a 3-volt battery. This is the positive of it, and this is the negative of the battery. Now the watch is off because there is no battery. As you see, guys, so I will power this watch by a small solar panel instead of a battery. Now I have to solder the two wires, one for the positive pole and the other one for the negative pole. The circular pole is the negative, this one, in the middle, this one. And the points are positive. I mean this one and the other one. The 2 points are the same wire, the same pin. As you see guys, this is the watch after soldering the wires. The blue one is the negative and the white one is the positive. Let's see how much the voltage and the current does the watch take. So we need a battery of 3 volt, just like this. It's a lithium cell. This is the positive and the other one is the negative, this one. Now I have to connect 2 wires to a battery by soldering. I've tried soldering the 2 wires to a battery and that didn't ever. The soldering wires to a battery need more heat for this operation, so that could make the battery damage. Now let's try a better idea. Why don't we use the isolated wire clip? Such as this one. As you see guys, this wire clip can hold 2 wires to a battery from up and down. One is for positive and the other one is for negative. As you see guys, but how to make the insulated wire clip, such as this one? So we need a wire clip, just like this one. Take off the black cover of the clip. This one. As you see guys, the clip the shrinkable tubes for wires and lighter to heat the shrinkable tubes. Such as this one. As you see guys, when you heat the shrinkable tubes, the tubes shrink on a wires, but this time the tubes will shrink on the wire clip pins. So cover the pins of a wire clip by the shrinkable tubes. Those are the pins of the wire clip, as you see, guys. The tubes should be fed to the pins of a wire clip. As you see, guys, the red ones are bigger than the black ones. Now I will make the 3 layers of tubes for each pin. These ones. As you see, guys, let's start with the black tubes. So enter tubes to the pins of a wire clip. Just like that. Take one of tubes and enter it. Just like this. Do the same thing to the other one. Just like that. Cut the extra parts of tubes with a scissor. Just like this. As you see, guys, the wire clip, you need to make it just like this. After that, open the wire clip and burn the pins of a wire clip with a lighter. Just like that. So open it and burn them. As you see, guys, complete the same operation with other red tubes. If you want to close a wire clip, you have to enter the black rubber cover between the two pins of a wire clip. Just like that. As you see, guys, that will help to protect the black layer of the pins of a wire clip, so the black layer of the pins will not be hurt by the teeth of pins of a wire clip. Just like that. as you see guys, and then cut the extra parts. Finally, as you see guys, and then cut them. Now you need the electrical tape to piece two wires into a battery. Just like this. Cut this one. Put it. Take other one and cut it. Put it. Take a battery and piece two wires into a battery. One for the positive pin, the other one for a negative pin. Just like that. Take the battery, this one, take the wires, the white one will be the positive. Take the tape and put it on the positive of the battery, just like that. And cut the extra part of the tape. Just like that. Complete the same thing with a blue wire but into a negative pole of a battery. Just like that. Take the tape and put it. Just like that. So the white wire is the positive, the blue wire is the negative. As you see, guys, now you can put a battery inside the insulated wire clip, just like that. As you see, guys, the battery inside the insulated wire clip Let's measure the voltage before connecting the load with the digital multimeter. Just like this, guys. This is the result of the battery voltage. It's 3 volt, as you see, guys. So the blue one is the negative, the white one is the positive. Now we need the test board, just like this one. As you see, guys, the test board so we need the test board to connect the pins of a battery with the pins of a watch. All these points on the right side are connected as one wire. These ones. They are just indicating to a positive pole. As you see, guys, the red line. And all these points on the left side are connected as one wire. These ones. They are just indicating to a negative pole. As you see, guys, the blue line. All the points of every row are just connected as one wire, just like these ones, or or these ones, or these ones. Now let's build the circuit of a watch, a swatch, and a battery.
This is a circuit.
This is the switch. When I click it down, it turns off, just like this. When I click it again, it turns on, just like this. But which two legs of a switch? It's the first one, this one, and the third one, this one. Now enter the switch on the test board, just like this. As you see, guys, after that, connect one pin of a watch to one pin of a switch. You can choose a positive one or a negative one, no problem. Just like this. So I choose the negative one of the watch. And then connect the other pin of a watch to a positive pin of a battery. Just like this. So the positive of the battery to the positive of a watch. Finally, connect a negative pin of a battery to the other pin of a switch. Just like this. Now the circuit is ready to work. Let's try the circuit. Turn on the switch. Just like that. Click on it. As you see, guys, the watch is on. And you can turn off the switch. Click again on it. But how much current does a watch take? So let's measure the current that a watch takes. So we need a digital multimeter for measuring the current. Just like this one. We're gonna use this. Now switch the key of the digital multimeter to the range of microampere. This is the meter. Just like this. So we have to take off the two white wires from the holes of a test board. I mean these ones. Take them off, just like this. As you see, guys, now we need the other type of wires, just like these two ones. They can hold wires of a digital multimeter and this circuit. As you see, guys, every wire has two clips. These two ones. This one and this one. So we have to insert a digital multimeter to a circuit in series. Now we can measure the current of a watch.
This is the circuit.
But before measuring the current of a watch, we should know that a digital multimeter is connected as one wire of a circuit. Let's measure the current of a watch. First, turn on the digital multimeter to the microampere range. Just like that. This is the microampere range. This one. It's directly on the DC mode. Now you can turn on the circuit by clicking on a switch. Just like this. This one. Click on it. As you see, guys, the result on the screen of the digital multimeter, it's 1.1 microampere or maybe 2. As you see, guys, Also, the watch is on. As you see, guys, it's working. So this is the current that a watch takes from a battery of 3 volt. One note, guys, when you start turning on a watch, it takes more than 1.1 microampere for a moment. Just like that. Did you see the result on the digital multimeter? That was very fast. The highest current that I could note, it was 25.3 microampere. This is the capacitor of this watch. This one. As you see, guys, the 2 pins of the capacitor. In addition, the empty capacitor takes a huge current at starting on a circuit. Now we are going to use this small solar panel to power this watch. As you see, guys, so this solar panel has some data such as this. The open circuit voltage 3.6 volt, the short circuit current 5 microampere, the rated power 18 microwatt, the ambient temperature minus 65 to 150 degree. So the blue pin is negative, the red pin is positive. I mean these two ones. Let's power a watch with a solar panel. Now we have to connect a watch with a solar panel. So we are going to connect the positive pins with each other. Also connect the negative pins with each other. So let's start connecting a circuit.
This is the circuit.
So I have soldered the wires. As you see, guys, these 2 points you can see the pins of the solar panel and the pins of a watch. So the negative pins are soldered together and the positive pins are soldered together. So the blue wire is negative, the white wire is positive. At this circuit, the power source is a solar panel and the load is a watch. This is the solar panel and this is the watch. As you see, guys. Now we must expose a solar panel to the sunlight. I mean this one. This is the circuit of the solar panel and the watch. As you see, guys, when I expose the solar panel to the sunlight, the solar panel starts producing electricity. Like this situation. When I cover the solar panel with my balloon, it stops producing electricity. Just like that. As you see, guys, the watch is off. When I take off my hand or my balloon, the electricity is back. You can see the watch is on. Let's see the voltage of the solar panel after loading the watch. So the voltage on the screen of the digital multimeter is the voltage of the solar panel after loading. It could be more than 2.9 volt or 3 volt, sometimes 3.1 or 0.2. As you see, guys, when I cover the solar panel, the voltage will decrease and the watch will be off, just like that. The voltage is 0.83 volt and the watch is off. When I take back my hand or my balloon, electricity will be back. If the sunlight is strong, the voltage could reach more than 3 volt. At noon, the sunlight is very strong, so the voltage of a solar panel after loading will be more. So it could reach more than 3 volts. As you see guys, the voltage on the screen of a digital multimeter, it's 3.12. But how about if there is no sunlight? In this situation, I used the old 100 watt light bulb to power a solar panel with a light. So I took the Osram, this one, the suitable voltage range for this lamp from 220 volt to 240 volt. As you see guys, 100 watt. Now you need a bulb holder, just like this one. As you see guys, the two pins of this holder you can enter it into an electrical socket directly without using wires. They wrote that a bulb holder can bear 3 ampere. Now you have to plug a lamp into a bulb holder. Just like this. This is the lamp, as you see guys. This is the pins, the two pins of the lamp. As you see guys, it's 100 watt. So plug it in. Just like that. These are the electrical sockets. They all have the same switch. This one, the red one. This is the line power, the black wire. Now you can measure the voltage of any socket with a digital multimeter. But you have to set a digital multimeter to the sign of the AC voltage by rotating a switch. Just like that. Be sure the two leads of the mirror are connected correctly. One of the leads is connected to the comb of the mirror. The other one is connected to the sign of the voltage, ohm and diode. I mean these 2 points. This is the comb and this is the sign of the voltage ohm diode. Let's measure the voltage of an electrical socket. Select any socket for measuring. So I chose the first one from my left. I mean this one. Enter the leads of the mirror into the pins of the first socket. Just like this. As you see guys, the voltage on the screen of the digital multimeter, it's 222 or maybe 3. Now you can try the lamp with a solar panel. So turn off the electrical power by the key and enter the bulb holder into a socket. Just like that. Hold a bulb holder safely, just like this, like this situation. And then enter it into a socket. Just like that. Turn on a light bulb. Click on the switch, the red one. Just like that. As you see guys, the lamp is on. Power the solar panel with the light of a lamp. You should decrease the distance between a solar panel and a lamp. Just put it down like this situation. As you see guys, the watch is on. So this solar panel needs a strong light such as sunlight. The sunlight gives us usually about 1000 watt per 1 square meter in Sana'a city. When I cover the small solar panel, it will stop producing electricity. Just like this. When I take it off, the electricity is back. When I turn off the lamp, the solar panel will stop producing the electricity. Just like this. As you see, guys, our watch is off. There is no electricity.
Note 3. Imagine the load is connected to a solar panel and the density of sunlight increases. The voltage and current of a load will increase. Note 4. The unit which we use to measure the density of sunlight is watt per square meter. Note 5. In Sana'a city at noon, the density of sunlight is approximately 1000 watt per square meter. Note 6. In this experiment, we measure the open circuit voltage of a small solar panel in volts. Also, we measure the short circuit current of a small solar panel in microamperes. Note 7. We cannot take all the electrical power of a solar panel while connecting a load directly from a solar panel. In order to get the maximum power of a solar panel while connecting a load directly, we should adjust the suitable resistance of a load. The suitable resistance of a load should decrease the voltage of a solar panel in a half. Also, the suitable resistance of a load should decrease the current in half. So the maximum power of a solar panel that we can take, it is about a quarter of the rated power of a solar panel. Note 8. If you cover a solar panel from light with the palm of your hand, the current of a solar panel will get weaker. But if you cover a solar panel from light with anything fully or put it in the dark, the current of a solar panel will be zero. Note 9. If the short circuit current is 5 microamperes and the current that a watch takes about 1.1 microamperes, the ratio between the two currents will be 4.54 times.
Don't forget to like, share, subscribe, comment, and turn on the notifications.